So make sure that you upload this video. I'm thinking that you've already uploaded it. So now we want to take the data over to, excuse me, over to graphical. Oh my goodness. So in graphical, we now have our initial velocity. Of course, we want to format this as a table because we ultimately want to take this over to Microsoft Excel. So let's see if this opens up in Microsoft Excel. It might open up the last document. If it does, we'll just do this process again. Yeah, when it starts looking a little weird like that, it might want to say something funny. See how it says it can't save changes? And notice it's the last thing that we worked on, those sinusoidal waves. So I'm just going to do this again. Share, open in, copy to Excel. This time it should open fine. All right. So now we want to convert and edit this information. So I'm going to say convert and edit. And this time we want to put this into a different folder. Well, it's the same folder, but it's just a different folder. It's initial velocity. So I'm just going to pop that information into this one. And you know what? I don't want to leave this like this. It's been a little cumbersome. So I want to put this as, I want to save this as data. Data collected. How about that? Whoo. All right. I'm just going to say save. Cannot connect the server. So let me make this a little bit bigger. I'm just going to double tap on A, double tap on B, C, D, and E. Now, make this a little bit smaller. We have time, we have our X position. Let me just go ahead and be, oh my goodness. So we have our time here, we have our X, we have our Y, we have our X velocity and our Y velocity. What we want is going to be based on a theory. So let's go to our theory real quick. And the theory is right here. So if you look at our initial velocity here, we just need our displacement in the X direction over time. And if we need to find time, we just need to find our displacement in the Y direction. G is a known value. It's in this particular case, the negative sign for G is here. It is a negative 9.81. So we're just going to put in 9.81 right here, and the negative sign is already accounted for. So all we need is our displacement in the X and displacement in the Y. So that lets us know what to actually program or calculate. We're not looking for time. I'm just going to hide that. We're not looking for our X and Y velocity, so I'm just going to hide that. And I want to check the integrity of the data real quick. I want to make sure that I have a 0 and then 39 or 40, 0, 0.39, 0, 0.39, 0, 0.39, 0, 0.39, 0.39, and then we have 0.00483, which is effectively 0 compared to 0.39. Okay? And then 0, 0.4, 0, 0.39, and then 0.39. So we have 10 sets of data or 20 points. And it's going to correspond for the Y as well. If you can check those, you can pretty much be assured that the Y is correct as well. So I'm just going to, before I even copy this data, I want to go back to the folder we were looking at, Dropbox, and I'm going to go to brass and initial velocity, and there's a template here. So I have the data collected here, and I'm just going to go into this template so we'll know what we need to copy and cut. And I want to show you the theory. So we're going to place our X and Y coordinates in B and C. We already know what that information is. It's in the other sheet. This particular document will calculate the X displacement and the Y displacement for us. So it's just going to be B2 minus, B3 minus B2 for this cell. And then for the Y, it's just going to be C3 minus C2. And then it's going to calculate our average displacement. If you look here, it's going to be F1 to F21. And so that's down here. Okay, and then we go down a little bit. You'll see that we have our average Y displacement here. And it's just going to be G1 to G21. And then the time of flight is going to be calculated immediately. So remember, it was that square root of a -2 times the Y displacement. In this particular case, it's the average Y displacement divided by 9.81. We mentioned that when it came to the theory. And now you have the initial velocity. The initial velocity is just going to be our average X displacement, which is h2, divided by J2, which is the time of flight. If we go back to our theory, you'll see that here. The time of flight, -2. And let me do this. It's not really what I want to do. I want to do this. Why isn't this showing up? So if I go here, you'll see that I have the initial velocity in the X direction. That's our K2. Then we have our time of flight. That's our J2. And all the rest of the stuff is just our average X and average Y displacement. So again, the time of flight is here. Square root of a -2. We go here. Square root of a -2 for the time of flight times the displacement in the Y direction. In our particular case, we found the average because we want to remove error, right? So that's our average Y displacement. And then we're going to divide it by 9.81, which is just G. And then our initial velocity again is here. It's h2, which is the average X displacement, divided by J2, which is our time of flight. And you'll see that right here when it comes to the initial velocity. Our average X, so we just took the average because it's an experimental technique, and then we have our time of flight. So what do we need to do now? Let's just go back and let's get that data and then paste it into this sheet. So our data collected. So I'm going to highlight both of these, copy, and then just go back to initial velocity, last name, first name, paste this in, and we're going to be done. At least that's what I think. Paste. Look at that. It calculates for us immediately. Okay. And once it calculates for us, it actually finds the averages for us. We know that the displacement in the Y direction is negative because it is a vector. So it has magnitude and direction. But so is the displacement in the X direction. It happens to be going in the positive direction. We have our time of flight and we have our initial velocity here. It's 3.1 meters per second. Okay, you can go back here and it should update. Let's go back to Dropbox. Under Dropbox, we can go into that particular folder, which is the initial velocity. And we should be able to see that our initial velocity is here. So I'm just going to select on that. We should be able to see all of the calculations done in there. And there they are. Beautiful. So I just want to rename this. And I'm going to say initial velocity Brass Eric. And rename that. Go back And once I go back, I want to go to initial velocity and select on this drop down and send link and share this link with Moodle, the STEM initiative site. And that'll be it for this portion of the experiment. We're going to use this when it comes to predicting the range. We're going to use some of the same information.